The Blohm Voss P170 is one of those aircraft designs that makes you do a double take. At first glance, it looks more like a futuristic racing pod straight out of a science fiction film than a conventional World War II bomber. Now, while Blohm Voss is perhaps best known for its oddball asymmetrical planes, the P170 stands out for its three-engine arrangement, one nestled in the nose and two mounted on the wingtips. Designed to be a high-speed Schnellbomber, the idea was to outrun enemy fighters rather than confront them. This short and sweet introduction kicks off our deep dive into the P170's background, the design's eccentricities, and the Luftwaffe's high-speed bombing doctrine that inspired it. Blohm Voss was a major German shipbuilding and aircraft manufacturing company. Before it dabbled in bizarre aircraft designs, though, the firm was already a giant in naval construction, turning out everything from battleships to submarines. As the aviation sector boomed in the 30s, Blohm Voss, often abbreviated to B&V, sought to leverage its engineering expertise in the field of aircraft design. One of the factors that set Blohm Voss apart was the willingness that they had of their design teams to push boundaries. Although many German aviation companies like Messerschmitt, Heinkel, and Junkers focused more on conventional designs, Blohm Voss almost had unbridled enthusiasm for experimentation. During World War II, this appetite for the unorthodox produced a high number of original prototypes and concepts. Some of these, like the BV-141, which was an asymmetrical reconnaissance plane, actually saw some limited production, though they never really became widespread. The P-170 was part of this broader tradition of pushing design norms, even by Blohm Voss standards. This was a quirky concept that bridged the narrow line between genius and folly. In a sense, one could argue that such audacity is precisely what keeps aviation innovation alive, but it also can cause some planes to remain firmly in the realm of paper projects. While Blohm Voss had a few practical designs that saw service, a significant portion of its legacy lies in ambitious proposals. Let's talk about Schnellbomber. It translates directly as fast bomber. The rationale behind the philosophy was fairly straightforward. If you can make a bomber fast enough, you wouldn't need heavy armament or thick armor plating. After all, no defensive turret can compare to simply not being caught in the first place. The Luftwaffe's leadership believed that speed could be the bomber's best defense. To understand how this mindset emerged, let's roll back that clock to the late 30s. Fighters at the time were relatively limited in range and speed. Early German bombers like the Heinkel HE-111 or the Junkers Ju-88 could still outrun most older biplane fighters used by some nations. By focusing on performance, especially speed, designers theorized that they could dramatically reduce a bomber's chance of interception. Early on, the strategy worked, especially when facing underprepared or underpowered opposition. However, as the war progressed, the arms race in aviation technology heated up. Allied and Soviet fighters rapidly improved, both in speed and climb rate. Eventually, the fast bomber doctrine found itself overshadowed by advanced fighters that couldn't just match but exceed the speed of many specialized bombers. This shift played a pivotal role in limiting the utility of designs like the Blohm Voss P170. But nevertheless, at the time that the P170 was proposed, the Schnellbomber concept still had enough momentum and prestige to spark daring projects. German engineers, spurred by the successes of aircraft like the Ju-88, still tried to tweak the formula to produce an even faster and more elusive bomber. That's where the triple-engine layout of the P170 fits into the story, a bold attempt to deliver raw speed above all else. Blohm Voss was never shy about defying convention. This is the company that created the BV-141, which featured an asymmetrical layout with a crew pod on one side and the fuselage on the other. And they also toyed around with the BV-238, which was a massive flying boat that, at the time, was one of the largest aircraft in the world. The penchant for originality meant that Blohm Voss prototypes often looked like they belonged more in a comic book or maybe an emulsive pulp fiction magazine rather than actually on the battlefield or in the skies. But the driving force behind these unconventional concepts was usually quite rational, to improve visibility, enhance aerodynamics, or maybe just find creative solutions to specific challenges. In the case of the BV-141, for instance, the offset fuselage was meant to offer the pilot an unobstructed view while still allowing for a powerful engine up front. In the case of the P-170, the triple-engine arrangement, 2 on the wingtips and 1 on the nose, it was intended to balance thrust and reduce drag in ways that a classic twin-engine or 4-engine design just couldn't. Although modern aerodynamic studies might question whether it could genuinely reduce drag, B&V engineers were convinced that cleverly positioning those engines could yield significant performance gains. This spirit of experimentation wasn't always welcomed by the German Air Ministry, which often preferred proven concepts rather than just crazy ones that couldn't be mass-produced rapidly. But even so, Blohm Voss managed to carve out a niche for itself among the major manufacturers by pitching radical solutions, some of which actually flew, while some didn't make it off the drawing board. When you lay eyes on the proposed design of the P170, it's not hard to think of sci-fi references like Podracers from a galaxy far, far away. Now, this aesthetic similarly is purely coincidental, of course. Now, the real impetus behind the bomber's shape was the pursuit of minimal drag and maximum thrust. The blueprint for the P170 called for 3 powerful piston engines, one centered in the nose with 2 more perched at each wingtip. These wing-mounted engines could spin propellers in opposite directions, one clockwise and one counterclockwise. The plan was to reduce the effects of propeller torque and hopefully yield some aerodynamic advantages. The symmetrical approach, at least in theory, meant that the aircraft could handle more predictably despite the unusual layout. The bomber's fuselage was designed to be relatively short, with a cockpit placed near the rear. This allowed for a substantial section of the aircraft to house the nose engine, plus any bombs that could be carried in an internal bay. Now, the P170 was intended to rely on almost entirely speed for its defense. The concept sketches usually show no defensive turrets or heavy armor plating, and the strategic philosophy was to get in, drop bombs, and get out before the enemy fighters could respond in full force. It's worth noting that design studies indicated a top potential speed of around 510 miles an hour, which on paper would make the P170 one of the fastest aircraft in the sky at the time. However, as we'll explore more, the actual operational speed would likely have been somewhat lower, primarily due to factors like drag from bombs, underestimation of structural weight, and always the real-world inefficiencies that crop up once you try to convert paper specs into metal and rivets. But one of the biggest questions about the P170 revolved on how well or poorly 3 engines would integrate aerodynamically. Typically, aircraft designers would place multiple engines along the wings, spaced symmetrically along the fuselage. Well, the P170, though, you had 1 big engine in the nose and then 2 out on the wingtips, so the advantage here was that the wingtip engines could theoretically cut down on induced drag at the tips themselves. By placing engines at the extremities, you could sometimes reduce the tendency for wingtips to generate some drag. This was also part of the logic behind other experimental planes that used tip-mounted propulsion. Another theoretical advantage was that the airflow around the central fuselage could remain relatively clean, free from lumps or bumps that could hamper the nose's engine intake or the pilot's field of view. Now, on the flip side, the triple-engine layout introduced a host of potential problems. The first was weight distribution. If one of the wingtip engines failed, you would immediately have a massive thrust imbalance. In flight, that imbalance could require significant pilot skill to correct, especially at low speeds, like during takeoff or landing, when rudder authority might be limited. It also created a complex mechanical challenge. Every engine would have to be maintained, serviced, and monitored, adding to the workload of ground crews and the design complexity for everything from fuel lines to engine controls. The P170 was already deviating from norms by placing the cockpit near the rear, so the engineers were juggling more than a few tricky elements all at one time. Technically, if everything did work as intended, all 3 engines were humming in harmony and all, the plane might achieve its impressive speed targets, but in the harsh reality of a wartime operation, anything that complicated maintenance or risked an engine-out scenario could be a serious Achilles heel. Now, German aircraft from the 30s and 40s typically followed the standard format of placing the cockpit around the nose or midsection of the fuselage. Pilots typically needed good forward visibility, especially in takeoff, landing, and in combat scenarios. But the P170 turned this norm on its head by positioning the pilot station toward the rear. Now, the official reason for that unusual placement was to balance the aircraft properly. With a big engine in the nose plus the bomb load, the design team likely feared that the plane would be too nose-heavy. By shifting the cockpit now to the rear, they could place vital crew and equipment behind the center of gravity, therefore evening out the aircraft's weight distribution. Now, of course, this arrangement would have introduced its own brand of challenges. Forward visibility could be compromised, which required a raised canopy or other design tweaks. It's not entirely clear from surviving documents just how big a blind spot the pilot could have had. In high-speed flight, typically at speeds pushing 500 miles an hour, any compromise to situational awareness is a big concern. Having the pilot so far from the nose could also complicate mechanical linkages. Things like throttle control, instrumentation, and engine readouts could require longer cables and more complex wiring. Aviation in the 40s often dealt with mechanical or rudimentary electrical solutions, so the more you elongated those lines, there was more potential for a system error. Now, given these factors, one could assume that while the P170 aimed to look sleek and futuristic, the actual user experience for the pilot may have been more of a nightmare. Now that said, Blohm Voss had a track record of making the improbable work in at least some capacity. They may have had a trick or two up their sleeve to mitigate those cockpit challenges, but with as many aspects of the P170 kind of going wonky, it remained theoretical, and it was never fully tested in a flying prototype. Another hallmark of the P170's design was the absence of a traditional tail-mounted vertical fin. Instead, the proposed plan was to utilize rudders on the wingtips. Now, this was a highly unconventional plan because most aircraft rely on a vertical stabilizer and rudder at the rear for directional control. Now, by moving the rudders out to the wingtips, Blohm Voss essentially integrated yaw control with the aileron-like surfaces on the outer edges of the wings. The thinking behind this might have been similar to the logic for placing the engines on the wingtips: potential drag reduction, a simpler tail section, and possibly better control authority at high speeds. However, wingtip rudders can behave unpredictably at various angles of attack. If you lose an engine on one wingtip, you might need a massive amount of correction from the opposite rudder, intensifying the risk of rolling and yawing uncontrollably. It's worth noting that in the realm of aviation, there were other experiences with tailless aircraft and unusual control surface placements. The German designer Alexander Lipsitch worked on delta wing concepts that eliminated the tail entirely. The Horton brothers experimented with flying wings that also minimized or removed tail sections. These radical ideas sometimes function well in niche areas, but typically required advanced knowledge of aerodynamics and control systems that just weren't fully matured at the time. In the P170's case, the wingtip rudders could have demanded precise manufacturing and alignment. Any miscalibration could lead to severe instability, especially at the high speeds that the aircraft was projected to reach. Moreover, if the design had progressed beyond the drawing boards, wind tunnel tests might have revealed new problems, such as vibration or flutter on the rudders at extreme velocities. These sorts of issues often only become apparent once you actually start physically testing the prototypes. The P170's proposed top speed of around 510 miles an hour caught people's attention. That's roughly in the same ballpark as some of the fastest fighter aircraft of the early 40s. If Blohm Voss had managed to deliver on that speed, it would have placed the P170 at the cutting edge of bomber performance, potentially well ahead of many Allied interceptors at the time of conception. However, there's a reason we say proposed or projected. Aircraft speeds on paper rarely translate perfectly into real-world results. When you add bombs, external ordnance, or even just the necessary armor for essential components, you start shaving off knots. Fuel load is another factor. If you want a decent combat radius, you've got to carry enough fuel, which adds weight and further cuts into your top speed. In the spirit of the Schnellbomber concept, the P170 was designed to prioritize speed above everything else. That typically meant a modest bomb load. Now, while some historical sources suggest that the P170 might have been designed to carry around 500 to 1,000 kilograms of bombs, or 1,100 to 2,200 pounds, that's significantly less than conventional medium bombers of the era like the HE-111 or B-25 Mitchell, which could haul upwards of 2,000 kilos or more. Now, for the Luftwaffe, the trade-off could be acceptable if the smaller payout could be delivered with near impunity, but it's not clear how the P170's range would fare. Now, speed's one thing, but you also have to reach your target with that payload. If you're piling on fuel for extended missions, you're going to add weight and reduce speed. There's a delicate balancing act that every aircraft designer has to perform, and in the case of such radical designs, the margin for error grows even narrower. Realistically, had the P170 been produced in any significant numbers, it may have seen its actual top speed drop closer to 450 or 470 miles an hour once it was fully equipped for combat. That's still very fast for a bomber in that era, but it may not have been enough to guarantee immunity from late-war Allied fighters like the P-51 Mustang or the Spitfire Mark IX, which were achieving speeds well above 400 miles an hour themselves. The gap becomes slim indeed, and speed alone isn't a foolproof shield. Look, speed is great, but if the aircraft can't turn, climb, or dive effectively, it's a disadvantage in the dynamic environment of aerial warfare. Even a fast bomber might need to perform evasive maneuvers if caught in a tight spot. The triple-engine design with wingtip rudders, combined with a rear-placed cockpit, suggests that the P170 might have been tricky to handle. With 3 engines, you have to consider the effect of torque, especially if one engine fails. The wingtip engines spinning in the opposite directions might have alleviated torque on the wings to some extent, but you still have that big nose engine adding its own torque component. Pilots in the 40s were accustomed to certain norms in their control responses. The P170 might have demanded a unique approach to takeoff and landing. Now, a potential positive was the likely high wing loading, which usually translates to stable flight at high speeds. A stable platform can be good for bombing runs. However, if the plane was indeed stable in the sense of being less maneuverable, it might have spelled trouble if an enemy fighter got the jump on it. In other words, you can run, but look, you certainly can't hide if you can't turn quickly enough to avoid an on-rushing interceptor. Without actual test flights also, all we can do really is speculate based on the known aerodynamic principles and design drawings. Yet the consensus among historians and aviation enthusiasts is that the P170 would probably have had very limited agility. Now that's not exactly a deal breaker for a bomber that depends on speed, but any mechanical or strategic hiccup, like running into a well-coordinated enemy fighter, would quickly lay bare on the design's limitations. Now, had the P170 proceeded beyond the drawing board, how could it have been used by the Luftwaffe? Most likely, it would have been deployed as just a fast tactical bomber or perhaps even a high-speed reconnaissance plane. This relatively small bomb load implies that it wasn't intended for strategic bombing. Germany already had heavier bombers for that role. Instead, the P-170 might have been ideal for quick strikes on high-value targets behind enemy lines, where surprise and speed were really paramount. Imagine hitting supply depots, bridges, or key infrastructure, and then zooming away before Allied fighters could scramble in full force. That was the Schnellbomber ethos in a nutshell. The plane could also be used to harass enemy airfields or shipping lanes if it could outrun enemy interceptors. One interesting possibility is that it might have adapted into a long-range intruder role, which was equipped with extra fuel tanks in lieu of maybe heavy ordnance to chase down or harass Allied bombers. It's important to remember that by the time such an aircraft could have been tested and produced, likely around 1942 or 43, the tide of the war was starting to shift. The Luftwaffe was increasingly on the defensive and resources were becoming scarce. The strategic picture was also changing. Fast bombers were less effective once the Allies gained air superiority, as the speed advantage could be negated by well-coordinated fighter patrols and improved radar systems. Thus, even if the P-170 had been everything that Blohm Voss had hoped it would be, timing and the strategic environment might have stifled its success. Germany found itself requiring more robust defensive fighters, night fighters, and jets rather than just specialized fast bombers. One of the more nerve-wracking operational concerns for multi-engine aircraft is that dreaded engine-out scenario. In a conventional twin-engine plane, if you lose one engine, you still have the other providing thrust on the other side of the fuselage. It's not ideal, and pilots have to compensate with rudder input to counteract that asymmetrical thrust, but it's a known procedure. With the P-170, you had three engines spaced that far apart, especially on the two wingtips. If you lose a wingtip engine, then you have to have a yaw moment that could be quite severe. The pilot would have to rely on the remaining wingtip engine and the nose engine to keep the aircraft balanced. Depending on the flight envelope, low speed, takeoff, or landing, this imbalance could be disastrous. Moreover, if the aircraft was at full power, especially near top speed, the stress on the airframe from a sudden yaw or roll moment could be intense. Not only does that risk structural damage, but it also puts the pilot in a perilous situation where regaining control might be highly challenging. This is where the unique wingtip rudders either have become a saving grace or an untested hazard. If they weren't adequately designed to compensate for such a large thrust differential, the plane could quickly enter a spin or uncontrollable roll. Now, in high-stress combat environments, engine failures, they weren't rare. They happened. Flak damage, bullet hits, or just mechanical breakdowns can knock an engine out. And the more complicated and unproven the layout, the higher the risk that a single hit could prove fatal for the aircraft and its crew. It's one reason why more conventional twin-engine or four-engine bombers would try to keep engines relatively close to the fuselage or distribute it in a way that would mitigate catastrophic imbalance. But beyond just the flight risks, ground crews would also face an uphill battle keeping a triple-engine, rear cockpit bomber in top shape. Every engine had its own set of components, cooling systems, oil lines, propeller gearboxes, and so on. With two engines perched on the wingtips, the complexity of fueling, oil checks, and mechanical repairs would all go up. In the 1940s, the more time an aircraft spent being serviced, the less time it was in the air, contributing to lower sortie rates. Additionally, B&V's penchant for unusual solutions may have required specialized parts that weren't standard across other Luftwaffe aircraft. Logistics are often overlooked in these discussions, but it's crucial. If you can't easily swap out an engine or a propeller assembly because it's unique design, you can end up with a maintenance bottleneck. And then there's the matter of controlling three engines from a cockpit that's all the way in the back. The cables, linkages, or early electric systems needed to monitor RPM, temperature, and pressure for three separate power plants. That would just be formidable. Each additional mechanical or electrical line is another point of potential failure, and in wartime, reliability is paramount. This type of complexity helps explain why certain advanced German aircraft, like the Heinkel HE-177, which was a 4-engine bomber with its engines paired in 2 nacelles, ran into extensive teething problems. Even modest design complexity can lead to big headaches in production and operation. The P170 would have almost certainly required specialized training for pilots and ground crew alike, training that by 1942 or 43 may have been in very short supply given the Luftwaffe's mounting losses and resource constraints. The Blohm Voss P170 remains one of those obscure paper projects that sparks endless speculation among history buffs. It showed plenty of daring, 3 engines, wingtip rudders, a rear cockpit, and a promise of near fighter speeds. Whether it would have lived up to those promises is really impossible to say, but what is certain is that it came too late, with too many question marks. And it was all during a time when Germany's aviation priorities were shifting rapidly toward jets and more practical fighters. Admired mostly today for its inventive streak, the P-170 stands as a fascinating what-if story in the annals of World War II aviation. And look, it's always fun to look at the offbeat side of history and imagine how a plane like this might have performed if fate and technology had given it a shot. Now, we hope you found this discussion both informative and entertaining, and if you enjoyed this deep dive into one of the most unusual bombers that never was, be sure to hit that subscribe button and keep up with more off-the-beaten-path aviation stories.